we will move toward probability distribution, right? We will move toward a different distribution that we have, which is, again, from chapter 5, 6, and beyond, we're basically using this type or different type of distribution. So chapter 5, we talk about the discrete probability distribution and binomial distribution, which is 5.2. So today we're going to do 5.1, and before we doing the before we doing the problem, let's take a look at a few definitions we have. So 5.1, we deal with random variable. Again, random variable, just like chapter 1, just basically tell you that each item have a equally chance to a curve, right, to come out. So again, it's basically the random variable for us here in chapter 5 is just a probability experiment. Meaning, again, you know, picking a roll of the dice, flip the coin, those are your random variable, right? So similar to chapter 1, reminder, go back to chapter 1 in terms of discrete random variable versus continuous random variable. So how do we know which one is discrete and which one is continuous? Reminder, discrete is where you can list your number as in your counting number, right? 0, 1, 2, 3, 4, 5 as a specific number. If you list your item as an interval, meaning if, you know, one thing I told you guys, if you can break down to a smaller unit, you can break down to a smaller group, then it's a continuous item, right? The other thing we have is the probability property of probability distribution. So again, what is the probability distribution? Is just basically a frequency distribution table. Last time that we deal with, it's just that now they break it down to each different probability in terms of the item that we have. And again, similarly to the probability that we had before, there are two properties that we have, which is, first of all, if we say that P of X, which is the probability of the event we call X, but in this case, the X that we have is some variable, right? Last time in chapter 4, the probability of the event can be anything. But now the P of X, which is this X here, is some number or some variable that we deal with, okay? So again, first of all, the probability of X have to be between 0 and 1. Remember, your probability will never be bigger than 1 and cannot be a negative number, will never be smaller than 0, right? So again, that's what we have for probability. And the other thing is the sum of all probability. The sum of all probability is equal to 1, which is, that's the maximum you have is 100%. Okay, so looking at this thing here, let's take a look at this example. The first thing is they want you to recognize, go back and ask yourself, basically determine which of this thing here is a discrete item and which of this thing here is a continuous random variable, right? So as you can see, one thing is for chapter 5, we only deal with discrete. And then when we get to chapter 6, we deal with a continuous item. Okay, so again, looking at this thing here, let's take a look at A. They ask you the amount of rain during the next thunderstorm. Can we list the amount of rain as a whole number, like 1 inch, 2 inch, or 3 inch? Well, looking at this thing here, as you can see, the amount of range is not how high, right? The amount of rain is basically how much, right? So hopefully, if you remember, we ask you, or as long as we can give in an interval, which is how much, then is a continuous item because we don't have a fixed amount, right? And again, next thunderstorm, we don't even know yet, right? We just know that, well, we can guesstimate between this group of interval, not a fixed amount of item, okay? And again, the height of a college, a randomly chosen college student, remember the height, we have feet. We can break the feet to inch. In inch, we can break into centimeter if you want to. In terms that we can break down smaller in terms of unit. And as long as a unit is a continuous item, right? So hopefully you guys see the difference between A, B versus C, because C, now they ask you the number of people in line at the bank, right? So again, the number of people, which is the number of people we can count as 0, no one in line, 1, 2, 3, 4, 5, which is, as you can see, the number of something. Most of the time, the number of something will be your discrete item because the number is just 1, 2, 3, 4, 5. Right? So again, looking at this thing here, the time it takes you to drive to the airport, you probably already guessed the difference between D versus E, right? If you see, the number, those will be your discrete, right? On your iPhone, I randomly choose an iPhone, the number of songs can be 0, 1, 2, or 3 or more, right? You cannot have, you cannot download half of the song, right? But anyway, this is just go back to how we distinguish the difference between discrete versus continuous, right? The amount of something most of the time will be continuous. The number of something will be discrete, okay? And again, looking at this thing here in chapter 5, as you can see the title earlier, we only deal with discrete item, which is looking at this thing here. The next thing they ask you is to verify. Verify if this is a probability distribution. So remember, what is the property of probability distribution? Well, there are two things that we need to consider of, which is your P of X. Your probability cannot be a negative number or cannot be bigger than 1. If that is the case, then the second thing is all of your probability, the sum of all probability, the sum of P of X have to be equal to 1. So if you look at this thing here, you probably see that A, is this a probability distribution? You probably say not quite, right? Why not quite? Because again, looking at this thing here, we know that we have a negative probability, right? Even though if you add this thing up, and again, I purposely doing this, which is even though if you add this thing up, 0.25, 0.65, negative 0.3, 0.4, if you add all this thing up, the sum of probability is equal to 1. But because the probability have a negative item, negative probability, that does not fit our property, right? So again, the property, I told you guys that your probability can never be bigger than 1 and can never be smaller than 0. So in this case, this is not your probability distribution, okay? So that's what you need to ask yourself is this, right? This is what you need to ask yourself is looking at this thing here. Remember, your probability distribution does not mention anything about your X. Your X is some random variable. Your X is some item. Your X can be any number they want it to be, okay? Now, looking at this thing here for B, is this a probability, discrete probability distribution? Well, the first thing is we claim through there is no negative number, right? No negative, not negative number. The X can hold negative number, but the P of X does not have any negative probability. So we know that the first thing check, all of my probability is between 0 and 1, right? And the second thing I need to do is I need to add all of this thing up, like 0.17, 0.25, 0.31, add them up to see if it's equal to 1, which is in this case is equal to 1. So I know that the first one checked and the second one is checked, which is looking at this thing here. If those are two checked, then we know that this chart, this table right here is our probability distribution, okay? And again, let's take a look at the C. Is this a probability distribution? So is C a probability distribution? And hopefully you say no, right? Why no? Because again, if you look at this thing here, if you're looking at this item here, which is again, the two items that we're looking for does not fit the description that we have, right? First of all, your P of X, you don't need to do the summation. If first of all, you see that the P of X we have bigger than 1. That's not it, right? Bigger than 1 is not one of the property. So again, looking at this thing here, we know it's no, right? So again, the second thing is if you add this together is more than 1, right? The maximum probability that you can get is 1, which is again, both of them does not fit the description that we're looking for. Therefore, this thing is not a probability, discrete probability distribution. Okay, so question of how to identify the probability distribution here. So the next thing they have is now we can use the probability distribution we can use the probability distribution to answer our probability question like before. So looking at this thing here, this is what they ask you is the 4 patients have made appointment to have their blood pressure checked at a clinic, right? Let X be the number of them that have high blood pressure. Meaning again, this thing here, as you can see, the X represent no people have high blood pressure, 1 person have high blood pressure, 2 people have high blood pressure, 3, and the maximum 4 of them have high blood pressure. And the P of X, which is the probability of none of them have high blood pressure, so on and so forth, right? So this is, do you agree? First of all, let's verify, let's check this thing here to see if this is a probability distribution, which is reminder, looking at this thing here, none of this probability is have a negative, and none of this probability is more than 1. So we know that it fit the first description. And if you want to check if you add all this thing up, it's equal to 1, which is we know that this fit the description of a probability distribution. Everybody see that? Okay. So looking at this thing here, they ask you take this item so that we can look at this item and answer this probability. So again, basically this is the question, right? If you go into this item, you randomly select what is the probability of, again, given this information, what is the probability of 4 of them? 4 of them have high blood pressure, right? So again, what is the probability 4 of them have high blood pressure, which is the probability is very easy to identify, which is again, this is the probability, which is again, the difference between this thing here is because they tested out, they got the probability. It's not like a dice, right? The dice will always be 1/6. The flip the coin will always be 1/2. This probability distribution is they give you some probability already, right? So again, they give you this probability, which is again, the probability of 4 of them have high blood pressure is 0.02, right? And again, go back to chapter 4, when you see the word or, which is reminder the word or is the mutually exclusive, right? In this case, it's mutually exclusive. Why? Because it's either 1 of them have high blood pressure or 3 of them have high blood pressure, because each of the probability is for the individual 1 and the individual 3, right? So again, we cannot have, 4 patients come in, we cannot have 1 person have high blood pressure and 3 people have high blood pressure, right? Because again, that's 4 people is here already, right? So looking at this thing here, basically, again, this is basically tell you, take the probability of 1 plus the probability of 3, which is again, looking at this thing here, the probability of 1 or 3 patient have high blood pressure will be 0.51. So looking at this thing here, try to find this probability is easier than before in the sense that now they give you the probability. You just ask yourself, what description are they asking us, right? What description they ask us, which is again, we just go in there and looking at that description. Similarly, right? Similarly, looking at C, they ask you find the probability of more than 1. Remember, more than 1, do you agree that more than 1 is 2, the 3, and the 4, right? More than 1, this is my more than 1, which is 2 is more than 1. 1 is not more than 1, right? 2 is more than 1. 3 is more than 1, 4 is more than 1, which is everybody see that to find this probability, all I need to do is just add those 3, right? So if I add those 3, the probability of more than 1 person have high blood pressure is 0.36, okay? And to go back to this item, which is the at least 1. The at least 1 reminder, if we go with our definition, the at least 1 is 1 minus none, right? Which is, what is the probability of none? Do you agree that the probability of none, if you look at this thing here, this is the none, right? This is none, which is no, this is no people, no person, none of the people come to this clinic have high blood pressure, which is, that's the none, right? So if you want to, you can use in this rule, which is again, we can take 1 minus the 0.21, which give us 0.79. Or vice versa, right? On the other side of the spectrum, we know that at least 1, the definition of, not at least 1, at least 1, right? The definition of at least 1 is 1 2, 3, or 4, which is again the other side we can do because of this thing here. We can say, well, I can just take each of this thing here and add them together. If you take the 0.43 plus this, you will get the same answer here. Okay, so again, the reason why I want to give you C and D is make sure that more than one does not include one. If you look at this thing, more than one is include the 2, the 3, and the 4, right? It's have to be more than one. At least one, meaning that, again, the minimum is 1 or more. Okay, so again, that's why we have C versus D, that the two numbers are different, because one of them is more than 1. We do not include the endpoint. We do not include the 1. At least 1, we do include the 1. Okay, so again, question with this thing here, how to use in your, how will they ask you relate to your probability distribution, and how to use your probability distribution to answer or to find the probability here. And hopefully you say, well, it's pretty simple, right? It's pretty simple because they give you all the information that you needed, right? And that's, you know, that's basically it. And now this is what they ask you to do is, how will you create a probability distribution if you don't have a probability distribution, right? So looking at this thing here, how do we create, this is, if you look at number 1, right, they ask you to construct the probability distribution for X. They ask you to find the probability of 3 goal will score, find the probability of fewer than 4 goal will score, right? So looking at this thing here, if you read the description, right, you read the backstory. They say the World Cup play every 4 years, start from 1930 and except 1942 and 1946. And again, the following table present this championship game, like the World Cup game. And again, there are 19 games so far from 1930 all the way to now, right? And again, they ask you, let X be the number of goals for this population. And now, how do we construct a probability distribution? And again, a small history. The reason why there's no World Cup between 42 and 46 is, anybody know? World War II, right?
The war. Mm-hmm.
Right. Anyway, let's take a look at this thing here. I want to connect this, which is, if you look at this table, this is your frequency distribution table, right? This is your frequency distribution table here, which is, how do we take this frequency distribution table and convert that to your probability distribution? So one thing is, if you remember last time, I asked you to construct a relative frequency, right? So last time we named this, we say a relative frequency distribution table. The only thing changing is, ladies and gentlemen, the only thing changing is, instead of say relative frequency distribution table, they changed the name to probability distribution table, right? So that's all they did is, again, how do we find the probability of this thing here, which is, again, the X, this the number of goal, right? This goal, they tell you X represent the number of goal, which is the game can have 1 goal, the game can have 2 goal, 3 goal, 4 goal, or 5 goal, right? So again, this is the number of goal in each game. Now, this is what the P of X is. Again, how do we find P of X? Well, to find P of X, we take the frequency, which is, again, there are 3 games that have 1 goal, right? And divide it to the total of game we have, which is, we take 3 divided by 19, which is, this is my distribution, or this is my probability, which is, again, they just changing the name. It's nothing new, right? We did this before. Last time they just say relative frequency. Now they change it relative frequency to probability. So again, the relative frequency is the same as probability. It's just that now they want to, or they gonna keep on saying probability, probability, probability. So again, one thing is, this is what we have. And again, if you divide this, is some, you know, is some irrational number, is keep on going, doesn't have a stop. So we have to find a stopping point. So I route it to 4 decimal place, which is, as you can see, all my probability is between 0 and 1. And if you look at this thing here, if you take all this number and you add them up, and again, because we do it in this case, because we round it up and round it down, because we're using the rule of round up or round down, we cannot keep on, if it's 5 or more, we round up. If it's less than 5, we round down, or not round down, we keep that number. And because we do that, this thing here just come out to be 0.999999999 because there are some rounding error in there, right? Later on, you will say that you will see that there's a margin of error, right? But for now, this is your probability distribution, ladies and gentlemen. And again, I know you say, wait a minute, Mr. Tran, the sum of all probability is not equal to 1. Well, it's close enough because our arithmetic, because we're using the rounding rule, that's why it's not equal to 1. Okay, I can force and make it equal to 1, change one of this, instead of 84, I can change to 85, and this become 1. But again, that will make a rounding rule wrong. So again, we have to pick one or other. So we pick the rounding rule. Okay. But again, looking at this thing here, everybody see how to construct your frequency, your probability distribution. It's just basically like like before, find your relative frequency back then. Okay. So take the number of frequency, divide by the total, right? 4 divided by 19, 7 divided by 19, 4 divided by 19, and 1 divided by 19. Okay. So now, once you have this probability distribution, life should be easy. Now, what is the probability? Find the probability that 3 goals will score. So again, looking at this thing here, we can see that the answer is just 0.3. You can see that the answer is just 0.368. But if you go back to chapter 4, do you agree that to find the probability of 3, meaning again, how many game score 3 goals, which is 7 divided by 19, right? This is the simple probability, which is again, looking at this thing here is the same as this item, which is that's what we have, okay? So again, as you can see, we're not doing anything new. We just present you a little bit differently, right? Instead of just find the probability of everything, we present you the table now. Okay, so again, what about find the probability of fewer than 4, which is a reminder fewer than 4, meaning again, if you look at this thing here, this are fewer than 4, or if you see that we already did that, you can just add this probability up, right? So again, fewer than 4, we do not include 4, which is again the 3, the 2, and the 1, right? Which is the 3, which is again 3684, the 2 2105, and the 1 1579, right? Decimal. So again, looking at this thing here, question on how do we construct your probability distribution, and how do from probability distribution answer your probability, right? And again, you don't need this probability distribution to answer the probability question here, right? You can see that looking at this thing here, we can just take this item, divide by 19, right? 14 divided by 19, you get that. Okay. Question with this example here: how to construct your probability distribution if they give you a frequency distribution table, and how once you have that, probably 2 and 3 should be easy. So again, the reason why we do this, the reason why we're using this probability distribution is we want to guesstimate, right? We want to ask ourselves, we want to know what to expect from the data, from this population. What do we expect the sample come out to be, right? So for instance, if we go back to this thing here, right? We have 19 games so far, which is the population of this thing here. The population of the World Cup is this. So again, given this thing here, we say, well, the highest probability is 36. We pretty much, let's say next year we have a World Cup, we can expect that 37% will have 3 goals, right? Meaning again, we're using this distribution to guesstimate our future item. And that's what the probability distribution do is we want to know if, based on whatever we have, what can we expect in the future? Now, what can we expect in a long run later on, as you will see, right? So again, that's what we're doing here is we will have some distribution, and from that distribution, we kind of estimate and guesstimate our item. So here comes the problem, ladies and gentlemen. Hopefully you guys see that determine if it's continuous or discrete, or determine if it's a probability distribution, or how to construct the probability distribution is the easy portion. The next three items, this is where we have in terms of given the probability distribution, can we find the mean item of this probability distribution, right? Can we find the mean, which is, this is what we have is the mean of the probability distribution is this, which is the summation of x times its probability, okay? So again, basically again, they tell you take the first x, multiply to the probability, take the second x, multiply to its probability, take the third, multiply to its probability. After you do that, you add them all together, the summation, you add them all together, that will be your mean, okay? And again, looking at this thing here, sometime or later on, you will see that the mean is the same as expected value, okay? And again, the expected value, which is later on, you will see that the expected value, if it's turned out to be positive, if the mean or come out to be positive, we say we expect a gain. If the mean or the expected value come out to be a negative, we will expect the loss, right? Meaning again, we shouldn't do that project if we have a negative expected loss, okay? So looking at this thing here, let's take a look at the other two items we have, which is again, go back to chapter 3. If we have a probability distribution, how can we find the variance and how can we find the standard deviation? Okay, so the last two items we have, which is again, this is your formula for the variance, but this formula is very hard to do by hand. So they say, well, this item, someone proved that this item is equivalent or is the same as this item. So instead of square them first, we basically multiply them and then we square them later, okay? But again, this is what we're going to do by hand if we were to do it by hand in terms of to find a variance, which is we have to take x squared, multiply to the probability of that x, and then add them up together, then minus the mu, okay? So again, that's the hardest part, is find a variance. Okay, and again, I will I will show you how we will do that by hand. And the standard deviation come in very easy, which is the standard deviation is just a square root of your variance. Reminder in chapter 3, if they give you the standard deviation, you square to give you the variance. If they give you the variance, you take a square root to find the standard deviation, which is the same as before. Okay, so again, the main thing is this, which is you have to find out, which is, let's take a look at this problem here. Let's take a look at this problem, which is again, this is what, if you look at this thing here, if you look at A, B, and C, they ask you to find the mean, they ask you to find the variance, they ask you to find the standard deviation given the probability distribution above. Okay, and again, make sure that when you do your homework, make sure that your horizontal your row is the x, and the p of x is the decimal here. Okay, so basically this is what we have is, again, this is your value. What story do they give us? The story is the age of the student in high school, right? So again, this is the age of the student in the public high school. Okay, so again, you can be either 13, 14, 15, 16, 17, or 18 in this public high school, right? And again, the probability of the 13 years old is this, so on and so forth. So again, looking at this thing here, you know, you can glance, and the probability is not have any negative or not bigger than 1. We're kind of good to go. And again, if you add this thing here is equal to 1, we know that this is a probability distribution. You know, I don't think they give you something, they ask you to find the mean, the variance, and standard deviation, and this thing is not a probability distribution. You know, I just want to mention it so that you can do it. So let's take a look at the formula, or let's take a look at the mean, right? So to find a mean, this is what you need to do is, again, as you can see, I just convert my item to my vertical vertical item, right? So this is what we need to do is to find a mean. This is what they tell you to do is take the x times the probability, right? Take the x times the probability, which is again, how do we find the x times the probability? Which is again, all you do is 13 times 0.8, which is again, take the x, which is the x value times the probability, take the x value times the probability, take the x value times the probability, so on and so forth, right? So this is what we have, which is again, this is all you did was, all I did was I took the x times its probability. And now to find the mean, right? All that is just a preliminary. Now to find the mean, they tell me to take this number, right? The 1.04, add it to 3.36, add it to the 3.45, add it to the 4.48, so on and so forth, which is if I add all this number up, ladies and gentlemen, that is your mean. If you add all of those items, which is again, this thing here, if we were, like I say, we do it by hand, we take the data, times its probability, and then add them up, which is again, that is my mean. Now, to find a variance, this is your variance. And again, bear with me here. To find variance, this is what you need to do is we need to take a summation, which is again, x squared times the probability, and then add all of those items up. So looking at this thing here, which is again, what do we need to find the variance? Well, first we need to find the x squared. What is x squared? It's basically 13 times 13, 14 times 14, 15 times 15, 16 times 16, 17 times 17, 18 times 18. So again, this is my x squared. And now I know that I need to take x squared times the probability, which is looking at this thing here. What do? I just take 169 times 0.08, which is the probability that I'm using here. Same thing go, I take the 196 times the 0.24, and again, I just take the 225 times its probability, and that is what I have, okay? So again, this is what we need to do is to find the variance is we take the x squared times the probability, our formula, and now all I need to do is add them up, which is again, if I add all of them up, this is what I have, which is 234.17. But that's not the variance, ladies and gentlemen, because the variance tell you.
For a minute before you move on.
Go ahead.
I said, can you leave that up for a minute before you move on?
Yeah.
Okay.
So looking at this thing here, ladies and gentlemen, if you look at this item here, this is tell you that you need to add them up. You need to add them up and then subtract the mean square. So what is the mean that I have, which is again, everybody see that I add them up, I have 234.17, this is what I have, minus the mean square, which is 15.25 square. So if I take this item and minus this item, my variance is 1.6075. Okay, so again, all of this preliminary that we did, which is again, find the x squared times its probability, add them up, take that item minus the mean square, which is, that is my formula right here. And once we have this variance, the standard deviation is very easy, which is again, looking at this thing here, the standard deviation is basically tell you, take this item and take a square root of your variance. So what is my variance? My variance is 1.6075. I take a square root of that, I have 1.2679. So again, this is what we have in terms of this, ladies and gentlemen. This is what we have in terms of the last item in 5.1. Well, not quite a last item, but the last thing that we need to calculate, which is find the mean, find the variance, and find the standard deviation, okay? So as you can see, this is how we were to do it by hand. If we were to do it, give me 1 second. So this is how we were to do it by hand, which is again, the other thing is this, ladies and gentlemen, which is again, let me share you a different screen here. Beside doing the, beside doing it by hand, ladies and gentlemen, what can we do? Well, we can, no, let me X this. besides doing it by hand, what can we do? Well, we can use our calculator to do our, let me go back to this problem. And again, so let's take a look at this thing here, which is how will you, for instance, looking at this item here, how would you find the mean, the standard deviation, and the variance using your TI-83 or TI-84, right? So how would we do this? Well, to do this thing here, just like before, we need to input in L1 and L2. Just like before in terms of chapter 3, at the end of chapter 3, which is the first thing we need to do is we need to hit stat and edit. And one thing, ladies and gentlemen, I think someone sent me the email and I think I forgot to respond, is whoever sent me an email and I forgot to respond, I'm sorry. If you happen to delete L1, for instance, if you look at this thing here, whoever delete your L1 or delete your L2, to get L1 or L2 back, you have to hit stat, go back to setup editor. You just basically click on setup editor number 5, press enter and enter again. You will get your L1 back. Okay, so again, if you delete your L1 or L2 or L3, whatever L that you delete, to get it back, you just hit stat, go all the way to number 5, which is set up your editor, and then press enter and then enter again. But anyway, let's go back to this thing here. Like I mentioned, if you want to clear this thing here, you have to go to the L1. Everybody see my calculator here, and you hit clear and then press enter to clear everything. But again, looking at this thing here, to find this thing here, instead of doing all this table, which is, as you can see, calculate this thing here can be very painful to do it by hand. And that's where your calculator come in handy, which is if you type in your X, which is reminder, your X value is your L1, which is my X value is the age, which is my age is 13, 14, 15, 16, 17, and 18. So everybody see that my L1, I will use, or my L1 is my X value. Now my L2 is my probability, which is reminder again, L2, my probability is 0.8. I put 0.08, so I put in 0.08. 0.24, so I put in 0.24. 0.23, excuse me, 0.14, and 0.13. Oh, I'm missing somewhere. I'm missing the 0.28. 0.28 for my 16, 0.14 for my 17, and 0.13 for my 18. Again, like I mentioned, make sure that your data are matched. Your L1 you have 6 data, your L2 you have 6 data. What's that?
0.03. Not 0.13.
Thank you. 0.03. So again, make sure we have our data correct. So once we have this data, which is your L1, your L2, all you do is you hit stat and you go to calculate, and we use the one for stat like before, which is again, for TI-84, like I mentioned before, if you have TI-84, your list will be L1, your frequency will be L2. If whoever have TI-83 like this, you have to manually type in L1, comma, L2, which is again, you have to manually type in L1, which is L1 is number 1 here. And in order to type L1, you have to hit second, number 1. And in order to type L2, you have to hit second, number 2. And again, your TI-84, you do the same, which is for your frequency list, you hit in second, number 2 to type in L2. Once you have that, you just put enter, and magically, this is what we have, ladies and gentlemen. Do you see X bar, which is 15.25, that is our mean. Everybody see X bar last time is our mean. That is what we have here, which is 15.25. That is our mean. Everybody see that? And what do we have here, which is, do you see sigma, which is, again, this is population standard deviation, 1.267872233, which is, again, 1.2679. Everybody see that that is where I have this number. And again, if we have 1.267872233, right? If we have this number as our standard deviation, remember, how do I find a variance? Well, I just take this number and square them, which is, again, if I take that number, if I take 1.267872233 square, I have 1.607,499, which is 1.6745. So everybody see where I have, again, how do we make our life a little bit easier? Which is, again, your calculator will help you out, right? Which is, again, to do that, which is type in your L1 and type in your L2, okay? So again, looking at this thing here, looking at this thing here, question before question with the calculator, how to use the calculator, which is, again.
Yeah. I have a question. The calculator, I have the TI-84. I was wondering how you, after you put in all the information, L1, L2, and then you go back to calculate, how do you put L1 and L2 again? I don't know how to.
Go over to calculate, and then your 84, you have that prompt, right? You have that prompt, you say list one, you have the list,
yeah,
and then you have frequency list, and then you have calculate. Agree?
Yeah.
So in the list, do you have L1 there?
Yes.
Okay, and then so in the list you have L1, you just click down to the frequency list. In your frequency list, you probably don't have L2, right?
Correct. So how do you add, how do you put that in there?
You hit second and then number 2.
Second number 1 and then second number 2?
No, number 1. Number 1 is L1. You have to hit second number 2.
Then 2.
Yeah. That will give you L2. Don't hit second L1. If you hit, don't hit second one, because second one will tell you to type in. I guess we can.
Yeah,
stop.
I'm confused. I'm not getting it.
Let's.
Question also, Mr. Tran.
What's that?
I have a question. I have the TI-84, and then for the X bar, I'm getting 15.5, and I checked my numbers, and I have exactly what we're looking at.
So if you have 84, let's take a look at 84, right? 84, this is what my 84 is, right? You probably have this or you have the other one, right? So again, 84, if you hit on, let me open this. So if you hit on stat, edit, and again, let me type in 13, 14, 15, bear with me here. This will be the last problem we will do for today. So if you got this problem, we will continue with this more of this thing here tomorrow. If you want to leave the meeting, reminder to type in your type something in chat. Make sure I have you. If you have questions, stay back, and then I can answer once I answer this question here. So again, if you want to go, have a good day, be safe. I will see you guys. I'm missing something. I cannot multitask, sorry. I will see you guys tomorrow. If you have questions, please stay back and I will answer all of your questions here. 03. So again, if you don't have the answer I have, make sure you have the right data. That's the one thing, is make sure you have the right data in. If you have 15.5, you might type something off. You might type, either L1 you have something off, or L2 you have something off. So so once you have this thing here, whoever have 84, you hit stat, right? And then you go over to calculate. So this is what you see, right? You see L1 here. So if you have the list L1, that's good. You go down to your frequency, agree? and then you hit second, number 2. That will give you L2, right? Only if you don't have L1. For instance, up here, let's say for your list, you see that for your list,
Yes.
if you don't have L1, then you have to hit second, number 1 to give you L1, okay? So again, to type in L1, you hit second 1 for L1. To type in L2, you hit second 2 for L2. And if you have L3, you hit second 3, right? So again, once you have L1, L2, you go to calculate, you hit enter, and they will calculate for you, which is 15.25. That's what we have. And again, 1.2678, that's what we have here, right? So again, if you don't have this number, if you have TI-84, you don't have this number, make sure that your data is correct. That's the one thing is, you might type in like I type in earlier, instead of type in 03, I type in 13.
Can you do that one more time? I'm sorry, I'm not getting it on my computer, on my calculator. It's like I'm going to stat and then I go calculate and then you go.
First of all, do you have L1 and L2?
Yes.
Do you have your data in L1 and L2?
Yes.
Okay, so you hit stat, go to calculate, and press enter. Right?
I'm not getting that screen whenever I hit enter on my, after I hit calculate.
Do you have TI-84?
Yeah, it's the TI-84 Plus.
The same one right here, right?
Yes,
The silver, I have the silver edition one.
It's the same. I mean, it doesn't.
Instead of enter.
What's that?
After you hit calculate, and she put the information in, press 1. I mean, say before she gets to calculate, press 1 instead of enter.
Press 1?
Yeah, go over to calculate and then press 1.
Okay.
It gave you a list.
That's not showing up for me. Like the way it's looking at on your calculator, it's not showing up.
Yeah, I have the silver edition as well, and it just says 1/bar stats.
Yeah, it says
enter. It's not giving me any of those either, any of those numbers either.
So, silver edition?
Yes.
Yeah, when I pressed the 1 just now, it worked for me. So when I hit the 1, then I was able to get the 15 point. Well, no, it's still giving me 15.5.
Look at your data. Make sure that instead of point, because last time I typed in 0.13 and the data is 0.03. So make sure your data is correct.
Mr. Trainer, I got the numbers, and I have the TI-84 plus CE.
I don't have the CI plus CE, but CE should be more advanced, should give you the same answer.
Yeah, I just had to type in the frequent list too, like the
you probably have to type in L2 as your frequency too. But again, I don't have the CE as a one of the screen because that's the advanced one. I don't have it. But again, so again, make sure that you have to press enter. The last one here, 0.03, press enter. So again, if you don't have the number that come out, check your data. So once you have this, right? Once you press enter for 0.03, you go and hit stat, and you go to calculate, right? Which is 1 for stat, which is number 1. You can either press number 1 or press enter, right? And I have this screen. You guys don't have this screen?
That is not coming up for me.
No, I do not have that screen.
It's showing like the way we did it before with just L1. That's what's popping up. The dash bar var stats, and then you enter how we entered the second L1. You press second and then L1 or L2 or whatever.
Okay, so if you don't have the prompt, then you have to do like the TI-83 then, right? If you don't have this prompt, if your calculator doesn't have this, then you have to use the TI-83 menu. Meaning you have to manually, basically you have to manually, so you have to manually type in L1, L2.
Yeah, that's what I just did and it came up.
Yeah, so you have to, if you don't have the prompt, you have to basically type in this, right? You only have 1 var stat. This is what someone told me.
Yeah.
So if you have only 1 var stat, then go over here, then you have to type in second number 1, comma, second number 2.
Wait, where's the comma?
Yeah, that worked for me.
The comma is right here. The comma is next to, is on top of number 7.
Oh, okay.
And then type in second number 2, and then
Okay,
press
yeah,
enter.
that worked for me too. Thank you.
So see if you can Google and reset. Maybe you turn off some feature on if you have this TI-84 plus